Hello and welcome to part 3 of Dev Maths and Stats Refresher Course Lecture 3. So here we're just carrying on with these examples of partial differentiation. Before I go on to these, I just note some terminology. This is called partial derivative of z with respect to x. This is called partial derivative of z with respect to y. One thing you might have noticed from yesterday is that when you have f of x, if you just write f dashed of x, that means the derivative of x. With partial differentiation, that's no good because you need to show which variable you're talking about. So a similar thing is to write f the small x here, meaning partial derivative of f with respect to x. Fy meaning partial derivative of f with respect to y. And sometimes I think that possibly this kind of thing is more helpful than all the other technical stuff for understanding the lectures, because I remember studying economics at first, it sometimes confused me that the lecturer what the lecturer was doing on the board, and they'd just written a tiny letter at the bottom of capital or labour or output or poverty. They'd written a small letter at the bottom, and I completely missed that that means the partial derivative instead of the original function. So if you start seeing these small letters appear at the bottom of variables, it means the lecturer is assuming you're talking about the partial derivative. So having made that point, let's just do maybe every other one of these. So these are just further examples. If it's starting to get easy, just whiz through or skip on to the next part. Sorry, I was going to clear this before I made the video. Pardon me. So here we got f of x, y is equal to 5y cubed minus x squared y. Is that right? 5y cubed minus x squared y. Okay. And so really it's practicing the same thing again. It's just to put in the notation that we're going to prep that as partial derivative with respect to x. Don't really need to keep writing all this. So this is constant, so it's just this one to worry about. So it's minus 2xy. Okay. Now for the other one, this is now a variable, so we have 15y squared. This is constant, so it's just the y. Then y power 1, so you just have minus x squared. So those are the two partial derivatives. And I've also used a slightly different way here. I've defined the function like this, in this form, and then told it to define the two derivatives. So 1 and 2 mean the two arguments, so it should give you that makes it write the things like that. It's partial derivatives that way. So hopefully that's what we got. Yes. Okay, let's skip this one and go on to the third one. So here, I think I'm going to drop the x and y, it's just taking too long. So f is equal to 4x squared y squared times 2x minus 8 to the power 5. So 4x squared y squared times 2x minus 8 to the power 5. So f of x is equal to okay, I will write this one out in full, but I think in future I'll just start doing, unless you'd like me to, I'll start writing them out in a shortened form. But when we do the x1, what we have here is a product. So it's this 4x squared y squared times this as a product rule. And then inside of here we've got this, which is a chain rule one. So let's just go through the stages off to the side. So the first problem is how you differentiate this. So if you imagine you had a function like f is equal to, if this is too obvious, just fast forward. This is for people that are finding it a bit tricky. So we can bring in a new letter like u to the power 5. This I can do, but I have to remember that u is actually 2x minus 8. And then you differentiate both of these, so perhaps here we could bring our notation. So, okay, so f with respect to u is 5u to the power 4, and u differentiated with respect to x is equal to just 2. And then to get the chain rule now becomes, if you write it in this form, to find f of x, which I want to find f differentiated with respect to x, the chain rule says you have to multiply fu, pardon the expression, with ux. Okay, it's supposed to be a u. So that's how the chain rule looks in with this notation. And then so it's just multiplying these things together. So it's 5u to the power 4 times 2. In other words, it's 10 2x minus 8, which is u, of course, to the power 4. Okay, so that's all this long bit of stuff here is just how we're going to differentiate this when we come to that. So then in the chain rule part is then looking at, if that's, I better not use u and v again, if I define this as a and this is b, then the chain rule says I need to get, okay, let's just make it a bit shorter. So that's a and that's b. So a dashed is, remember for this one here, oh, I shouldn't use dash, that's bad. I'm going to use ax because we must be clear now we're talking about differentiate with respect to x. So ax is 8x y squared. That's treating that as a constant, differentiating this. Space there. And then differentiating b. So b differentiated with respect to x. This part, this is all the work we did here with the chain rule. So that's the 10 2x minus 8 to the power 4. Just this bit here. So now we can piece together the final answer for derivative with respect to x, which is, remember the good old product rule means to this differentiated, so it's ax multiplied by this kept as it is. So it's a 8x y squared, that's differentiated times b left alone, 2x minus 8 to the power 5, plus the reverse, which is a left alone, 4x squared y squared times b differentiated times 10 2x minus 8 to the power 4. And then you can try and simplify this. Let's not spend too much time on that. Actually, so this would just give you 40. And then to do fy, this one, fy will now be much easier. Well, will be much easier. because when you come to y, this is just a constant, this is just a constant, so you're only considering this, so it's just 2 times the 4 gives you 8, x squared stays there, this becomes y, and this is still there as a constant, just multiplying it. So that's finished. So notice in this example that to find the partial derivative with respect to x took a whole lot of excitement over here. To find partial derivative with respect to y is just instant, because there's only this is the only variable, effectively. Okay, so that's the answers. When we look at the answers, you may have to use some imagination to see that this is correct. So hopefully it is. That looks pretty simple. Yeah, there's 40 is coming from the 4 times the 10. That's correct. Okay. So, okay. That's 11 minutes already, so I'll put the remainder of the examples here in the next video. So thanks for watching.